Okay, so I must have given you some time in class to finish this one. Some of you probably got it finished. So in the purple, I've got negative 2 squared minus 2 times negative 2. And in the red, I have 7 plus negative 2. So what did the purple end up giving me? 4 plus 4 gave me 8. And the red, 7 plus negative 2 was 5. And so 8 times 5 gives me 40. Now, I have seen some people that were not getting 8 for the purple part. What kind of mistake can you envision for this part that I highlighted in the green? What kind of mistake do you think they could make right there? They didn't put the parentheses when they typed it in their calculator. So be careful on that. Please make sure you're putting the parentheses in when you're figuring that out, okay? Question 8. For the first part, I just want f of x over g of x. So how hard is this going to be? What is the f of x function? Come on, what's that f of x function? Any thoughts out there in TV land?
Oh, can I just tell you what I wrote down?
Tell me what you wrote down for the top.
X squared, is that X squared?
Yep.
Plus 7 X,
Good. What do you got for the bottom?
2 minus X.
2 minus x. Folks, we literally cannot do anything to simplify that. So this instruction right here to simplify your answer. All right, well, make sure you're concentrating on this and writing stuff down. Okay, now, don't try to get all fancy and cancel stuff out. That's not going to work. Now, if you can factor that, I might pay more money for it. By money, I mean extra credit, right? But if you can factor that thing, it still won't reduce or cancel out. Thank you. What are they asking for in the second part? What are they asking for right there? What do they want me to do? Plug in 6. Now, remember how I said to you before? Only use that answer if you trust it. But how the heck would you screw it up? I mean, you put one thing over the top of the other. That's it. I think it would be really hard to mess that up, right? Because there's not even any simplifying or doing anything with like terms or anything like that. So literally plugging in a 6 right there is a great idea. I don't care if you give me the answer as a fraction or a decimal. So 6 squared plus 7 times 6 over 2 minus 6. Go. Figure out what we get. Decimal or fraction, I really don't care. Could take your favorite pick. 36, 7 times 6 gave me 42, and 2 minus 6 gave me negative 4. What did we come up with for a final answer? Say it again. One good answer would be negative 39 over 2. Some of you might have written negative 19.5 or negative 19 and 1/2. I don't really care whether you write a fraction or a decimal. It's completely up to you. So I'm flexible on that for grading purposes, especially if you're going to show me all this cool work over here. Okay, so on number 9, what are they asking me to do? They want me to plug in -3 to the f function. They want me to plug in -3 to the g function. And they want me to divide them. So figure out the red, figure out the blue, and divide them. We had 9 plus 6 on the top. We had -1 on the bottom. What's that give us? What is 9 plus 6 all over -1? -15. Several of you did get that correct. Nice job. Now we get into the second topic of this particular section, which is finding the domain of these weird functions. A lot of these functions that we deal with will allow you to put in every single number in the universe. The ones that don't are fractions. I want you to look at this very simple fraction that I wrote in the blue box, 1 over x. Can you tell me the only number in the universe that you cannot put in there for x? 0. X cannot equal 0. Because we know that 1 over 0 is undefined or non-existent. You can't divide anything by 0. Okay. Now, so we might say something like this for the domain. All reals except x equals 0. Some of the questions are going to say it like that. Some of the questions are going to say it different than that. Some of them are going to use this kind of notation, x does not equal 0. But hopefully you get the idea that the only number in the universe that you can't use for that little simple fraction is 0. You can use anything else. Look at question 10. F of x divided by g of x. That's f of x over g of x. That's what they wanted me to look at. Zero's okay now. What's the one number in the universe which would be a major problem if I put it right there? What is the one number in the universe that would be a major problem? 8. 8 would be a big deal because I would have 8 minus 8 on the bottom and it would be non-existent. So I'm literally looking at this part right here to figure out what doesn't work. Now, for those of you who want to see the math involved in that, it looks like this. 8 minus x equals 0. You can actually take that denominator, set it equal to 0, and solve it. Subtract the 8 over to the other side. Divide by a -1. And you can see the problem that occurs. So, every real number in the universe works except 8. The only thing you're looking for is a denominator. Denominators cause the exceptions. Denominators cause the exceptions. If you don't see the denominators, it's going to be all reals, all reals, all reals. Go back up to question 3. We skipped question 3 a while ago. They're asking me to add two functions together. All right, 6x plus 2, 9x minus 3. Want to add those two functions together, tell me what I end up with. 6x plus 2 and 9x minus 3. How many x's would that be? How many x's? How many? 15. Perfect. 15x minus how much? Minus 1. All right. Now, here's my question. Do you see any denominators? No? Is there any number in the universe that you can't multiply by 15 and subtract 1? Absolutely not. So the answer to this question, is it going to be A or B? If you say A, then you got to tell me what number in the universe you can't put in there for x. But if you think you can multiply every number in the universe by 15 and subtract 1, well then guess what? You're going to be choosing letter B. And that's exactly what you need to be realizing. If you don't see a denominator, then there's no exception. The exception is the part that's coming from that denominator of the fraction. So as we go back and start working on these other questions, like number 11, we're going to be looking for denominators. So we're adding f of x and g of x together. What do we get when we add f of x and g of x together? Well, you got the f function, and you're adding the g function to it, and if you add those together, what do you get? Show me what you think you get if you add those together. Just add them together, that's it. No, they're not like terms. So you really just you can't combine any of them together. So if you just circle the answer that you have right there, the whole thing. If you circle it just like this, I would have to give you credit for that. That's not true. This is true. Now, she wrote it differently, which is exact. I would probably write it that way too, but there's nothing wrong with your answer either. Writing it in decreasing order of exponents. I'm not sure what square there. Those are both to say the same thing. You can't. There's no like terms to combine. Hopefully you realize there's no like terms to combine together, so you literally come up with 2x squared plus x plus 4. There's nothing wrong if you wrote it x plus 4 plus 2x squared. Some of you might have done that too. And there's nothing really wrong with that. You know, we like standard form where we have decreasing order of exponents, but there's nothing magical about it. What's the domain of that? Do you see any fractions to worry about? No? So which domain are we dealing with? A, B, C, or D? Yeah. 2 of you said C. You are correct. There's no fractions to worry about, so you are literally just dealing with any number in the universe. Okay, jump to 12. Now we're subtracting. We got 3x plus 2 minus 2x squared. I don't really care if you leave it like that because there's no simplification that can happen, or if you write it like this, negative 2x squared plus 3x plus 2. If you like to write it in decreasing order of exponents, that's the way a lot of math teachers would do it, but there's not a whole lot of simplifying you can do here. What do you think about the domain of that? A, B, C, or D? Are there any denominators to worry about? If there aren't any denominators to worry about, then what is it? All real numbers, right? So D is correct. If there are no denominators, you can be guaranteed that you're going to have all real numbers. Now, there are other exceptions in the universe which we are not going to deal with at the moment. We're focused on the denominators. So in this particular case, number 13, I've got the g of x function, 5 over x minus the f of x function, 8 minus x. The only simplifying I'm going to require you to do is distribute that so that you have the signs correct. If you take a look at the answer sheet, you'll get confused because they decided to get like denominators, and I'm not going to require you to do that. But distribute that. Tell me what you get. Distribute that. Tell me what you get. Now make a choice. If you distributed correctly, now make a choice on your domain. I do see a fraction that you should be worried about. So if you got to that blue part because you distributed the negative 1 through that parenthesis, make a choice on what you think the domain is. Now look through here. I see the denominator right there. So what is the blue number I cannot put in place? That's right. 5 over 0 would not be possible. That's why. We're trying to stick to just denominators for now. We'll eventually get to square roots down the road, but not right now. We're just going to deal with our denominators. Get that up to the point where we can handle it. So what's my domain? What's the only number you can't put in there for x? 0, which means choice A is your domain. Every number except 0. 0 causes a problem in the denominator of that fraction. Question 14. We want f of x over g of x according to what they say here. So what would that look like? What goes on the top? Anything? 4 minus x, good. And what goes in the bottom? 1 over x, good. I'm not going to ask you to simplify that. That might be an extra credit thing. If you want some extra credit, I could show you how to do that. For those of you who would like the extra credit, you do something like this to the top and the bottom. But this would be a completely extra credit version of this. What is x times 1 over x for those of you trying for extra credit? Well, it'd be x over x. What is x? Anything divided by itself? 1. Okay, that would be an extra credit thing, not a requirement. So I'll erase that for now, just so that people don't get confused when we're taking a look at this fraction. We see a denominator. We see a fraction right there. So what's the domain? A, B, C, or D? Is it all real numbers? Is it letter B? No? What is it? It is A. Any number except 0. 0 causes me a problem. Okay, now question 15. I'm going to do this real quick. You do not have to write this first part down. So I wouldn't worry about this. The multiplication part, I'll show it to you very fast. I'm going to do this kind of like we did in elementary school. 3 times negative 12 is negative 36. 3 times negative 5x is 15x. 3 times 3x squared is 9x squared. Yes, folks, I do know that we didn't do this with polynomials when we were in elementary school, but the same idea is happening here. I'm putting things in like columns. 3x cubed. Okay, so now we add things together. We get 3x cubed plus 14x squared plus 3x minus 36. My biggest concern is not that you can do that. My biggest concern is that you can tell me what the domain of that thing is. Say it again. All real numbers. Do you agree, disagree? There's no fractions in the whole thing, so yes, all real numbers is correct. That's what you're paying attention to. You're looking at the overall answer, looking to see if you end up with any fractions. I'll either probably multiply that out for you or not have that one on your test. So we will be doing, you'll be taking 30 minutes of notes tomorrow on 2-3. 2-3, however, is not on your checkpoint quiz or test for Wednesday. Okay, we'll be ready for our checkpoint test on Wednesday. But the 2-3 notes that you're taking are not going to be a part of that test. Just what we get through today. Okay, question 16. So it would be really important that you bring your notes on Wednesday. So we want f of x over g of x. 3x squared minus 23x plus 14 all over x minus 7. There is a possibility of extra credit in this question, which I'll show you in a minute for those of you who are interested. Which domain are we looking at? A, B, C, or D? Which one? D, I agree. Right? Anything except for 7, right? Right there, we have a denominator. If I plugged in a 7, I would have a major problem. And for those of you who want to see the quick math on that, you would simply be setting it equal to 0 and solving to find the exception. And I will, if you can factor that numerator, you probably would see some reducing. Factoring is probably not something you've done in a while, so I can quickly go through that. Now, when I was in high school, nobody showed me the Berry method. They just made me guess and check and guess and check and guess and check, and it was very frustrating till I got the correct answer. But for those of you who might remember foiling, the Berry method is a very slick way to do this. I multiply the 3 times the 14 at the end. For those of you who do not want to try for the extra credit, don't worry about this part. This is not required. Things that multiply together to give me 42, but add up to 23 would be 21 and 2. The 3 comes back into play and in both of these, and then I factor out any GCFs. Looks like there's a GCF here. That would be x minus 7 and 3x minus 2. You can guess and check your way to that answer too. So for those of you who are interested in the extra credit, do you see anything that might cancel out? The x minus 7s. So if you gave me that answer right there, showed me all kinds of work to get there, you would definitely be getting extra credit for that, okay? But that's not a requirement, folks. The requirement is that you understand how to find the domain of that fraction. Okay, I need to keep moving here. 17, I got x squared minus x plus 1, and I'm adding 5x plus 3. Okay, they've asked me to add those two functions together. I get x squared, my middle term is 4x, and my last term is 4. What is the domain? A, B, C, or D? A. Are there any denominators to worry about? No. No denominators to worry about. At all. If I get to 18 and 19, I'll come back, but I would really like to focus on 20. Make sure we get this one covered. Go ahead and write out f of x over g of x. F of x over g of x. No, we're not done. F of x over g of x. In order to answer this question, I think you're going to have to factor your denominator. I think. This one's a lot nicer than the one that I told you was for extra credit. This one's much nicer. So break it up into your 2 parentheses. Factor that denominator, because you'll need it for this question. Think about factors of 4 that add up to 5. Factors of 4 that add up to 5. Factors of 4 that add up to 5. So like 2 and 2 don't add up to 5, right? Right. So it's obviously not 2 and 2. Can you think of two things
that multiply together to give me 4 besides 2 and 2? Correct. And they do add up to 5. So that's what I would use. So they actually have to add up to negative 5. So you have to have x minus 1. That kind of rings out. It's been a while, I'm sure. I'll see if you can answer the domain question.
Okay, so what are the two numbers? This time there are two numbers that would cause a problem. If you were able to factor it into x minus 1 and x minus 4, right, because 4 and 1 add up to 5, and they both have to be minuses to get you a negative 5. What are the two values which would cause you problems? Well, if you set these equal to 0, x minus 1 equals 0, x minus 4 equals 0, and solved both of them, you would find out that the two exceptions are 1 and 4, which would be choice B in this case. So this one had two exceptions in the bottom. 18 and 19 are pretty much duplicates of the other types of problems that we've done. Remember, you're looking for denominators. Denominators are the problems for the domain. If there are no denominators, what's your domain always going to be? All real numbers.
All real numbers.
Yeah, there you go. Just keep it all real, folks.